really appreciate you coming out tonight to learn, to exchange. First of all, I am honored to be here and honored to have an association with Bijan for these last several years. So if you have questions as we go through a presentation this evening, please feel free to ask. If you saw something back there on the table earlier that you want to talk about, we will be happy to talk about it at the conclusion. If you want to take literature, please take me home light. The later I go home, the happier I am, because that means I have to load and unload less later. But feel free to pipe in with questions. We'll also have questions at the end. This is an AIA accredited class. Whether you have an AIA membership number or not, you can get a certificate, okay? So when you write your name down on the sheets, and we'll ask for your name a couple of times on the sheets, one for Bijan's records that he can pass into AIA, another one for another group that I'm going to mention in just a moment. But these things are all, something that, it's a matter of education. If I was sitting in your chairs tonight, I would want to be educated a little bit about what I'm going to present with you. Just like last time I was here, I hope I left those of you who are with me again, thank you again very much, several of you that were here last year when I was here. I hope I left you with something that was a little bit of an educative value to you. But I feel that this is an educational process. I'm 61 years old, but I refuse to grow up. So take it for what it's worth, okay? Anyway, let's go through the slides here. Tonight's presentation is an overview of concrete masonry units, and then the standard for concrete masonry units, which is block, okay, block walls, which is known as the Astm C90. That's fine, thank you so much. This presentation is not only accredited for CEU credits, of which you get not one but 2 credits thanks to Bijan and his communication and his rapport relationship with AIA, but it's also under the auspices of what's called CPG, or Concrete Products Group, which is who I report to with my sheets. Okay, so what we're going to do now is we're going to go through the objectives of this program, which is what everybody, those 2 governing bodies, recognizes. First, we want to have a general understanding of concrete masonry unit production. What is in a CMU and what aesthetic options are available? Second, what Astm C90 covers. The density-related products and properties of CMUs, because there are some different densities that we're going to be looking at this evening, and how compressive strength is evaluated. Third, how heat capacity and something called thermal mass contributes to the thermal performance of CMU walls. If we don't know or are not familiar with thermal mass, I'll mention a little bit about thermal mass as we get into it. And then lastly, how to achieve IECC. A question, Mike, what's IECC? It's the International Energy Conservation Commission code, and they have various compliances using CMU for thermal performance and also air barriers. I did represent last year air barriers, so if you want to ask questions about air barriers and CFMs and cubic feet, bring them on. One thing I will say about this presentation, it's a nationwide presentation. Throughout the United States, this presentation is made. However, there will be slides here that may not be as applicable to us in Southern California as they are other parts of the country. So I'll mention these things so that you're a little bit familiarized with them. Okay, what is in a CMU concrete masonry unit? Cinder block, okay? Just a show of hands. Has anyone here ever worked on projects where you've had CMU, concrete masonry units? Raise your hands. Great, okay, good amount of people, great. For those of you who haven't, I was with you 5 months ago. I didn't know anything about CMU except to look at it and say, well, that looks pretty, and it's durable. Okay, so now this is where one of these slides, it says it's not used anymore. That's not true. In Southern California especially, and even in Northern California, because of the raw materials availability, there's quarries that are drawn for CMU and for block applications that have cinder in them. What does cinder do, Mike? It lightens the block itself, okay? So it's not as dense and it's not as heavy as other types of block. So that's one thing that I have to mention, that there is cinder block in the West Coast area where aggregates are needed to be drawn from quarries, because we do need it here. Now, but fly ash, okay, it says it can be used as a pozzolan, okay? Well, cinder blocks is used as a pozzolan too, but fly ash, unfortunately, is not as dense as cinder block, so that's why cinder block is used, okay? Now, cement block is a component of CMU, but a small percentage by weight, okay? I want to mention a couple of other things. There's some graphic information here. I'll mention this, that cement for block is only encompassing about 10% of the overall weight, okay? What else goes into it? Sand and aggregate, okay? So there's not a lot of cement in there, and we'll mention that in a moment after we go through a couple of other aspects of cement. If we were looking for high strength, we're going to get a range of about 1 or 2% more. So somewhere in the 10 to 12% range, we're going to have a high strength block, okay, which is a higher compressive strength, whereas normal block will be lighter and not as high. As far as the Astm C90, the high strength does have higher requirements. It's almost double, as a matter of fact. So that's important too. Then for architectural purposes, the aesthetics of the block, the architectural block for cosmetic purposes in a sense will have both pigments and other admixtures which encompass 1 or 2% more to make it look like it belongs and ties in with what's being done, whether it's a perimeter wall or if it's a building, retaining walls, site walls, garden walls. You know, there's a lot of different kinds of wall applications that you can work with. Then there's also something where block is broken down by weight. I mentioned lightweight earlier. There is lightweight block, and then there's also normal weight block. But in this area of the country, there's a third weight, and the third weight is medium weight block. And the next thing we'll see later in some graphs where we have medium weight, kind of like being the best of both worlds, because there's some good advantages of lightweight block, and there's some good advantages of normal weight block too. So we'll go in there. However,
Wait, can we ask questions as we go
by all
on,
means.
or
Sure.
you want us to wait?
No, ask questions as you think of them. If you have something now, go
Yeah,
ahead.
I have just one question. You mentioned about different strength of concrete blocks.
Yes.
I mean, does that at all relate to the cells? I mean, when we fill the cells,
Yes.
or it's just the concrete block itself?
Great question. Thank you. The block itself, and we'll have something on ASTM later, but to answer your question, the block itself started out when ASTM became the governing body of CMU and concrete block, about 1900 PSI compressive strength or greater, okay? But in 2013, on a nationwide wholesale change, it was up to 2000 compressive strength PSI. But if we went with high strength block, let's say we're doing a hospital, a school, detention center, a prison. You know, all these are very practical for building applications where they're not retaining walls, they're not perimeter site walls, things like that. The PSI compressive strength is 3,750 minimum for high strength block. So there's like I said, it was almost double earlier. Have I answered your question?
Yeah, just the block itself, without the...
Without grout.
Without the grout.
Without the grout, yes. The grout's going to make it even stronger. But also remember, and we're not going to see anything here, but again, I have to qualify, because they don't mention anything about rebar. Rebar is very important to us, because if properly placed, it can actually be stronger than a framed wall. A framed wall, you know, has minimum load values for shear value and tensile strength, okay? And framed walls have their places. Framed buildings have their places. But block that has a fully grouted block wall with rebar in it has tremendous value. In fact, in Florida and in the Keys of Florida and in areas of the Caribbean, okay, because of all the hurricanes that they've had over the last 50 years, many buildings, when they're retrofitted or when they're built in Florida alone, are going to block, okay? I'll give you a local example here. I was just in Santa Monica a few weeks ago working with an architect right down the street, around the corner, I think, from here, and they're doing 1601 Lincoln Boulevard. That's the new transit center, okay? I remember transit centers years ago, like the Greyhound bus terminal, where they built frame buildings for that. But they're concerned about earthquake, they're concerned about durability, they're concerned about a building lasting 40, 50, 60 years. And that's where CMU comes in real handy, okay? It does. The other thing I want to pass around, I'm going to give this to Mo, is on this side, this is called precision, okay? Precision, okay? Normal gray block, I think I mentioned this earlier, is 10% cement. So you say, well, Mike, what is poured in place concrete in its cement content? It's actually 13 to 15%. So it's not that much more, but you get much more because of the block being fully grouted and also reinforced with steel. So you got a real durable structure, whether you build a wall or a building, if you do have those two factors incorporated into your block. And it doesn't matter if it's lightweight, normal weight, or something in the middle, medium weight. Any other questions? One other mention here is there is implication also on fire, okay? We're very conscious here in the state of California with fire codes, okay? So as Bijan mentioned, Mike, if I have a reinforced, grouted, as he mentioned, grouted, fully grouted block wall for a building, okay, can I get a fire rating? The answer is yes. The maximum fire rating allowed is very, very likely and possible, and it's easy to attain with a fully grouted block wall. And we'll go through some slides and talk about that a little bit later. Also, acoustical value, okay? The acoustical values are great with block wall, and again, fully grouted, okay? I have some flyers back there on pre-insulated block, okay? Pre-insulated block is good for thermal protection so that the building stays cooler in the summer and warmer in the winter because of pre-insulation of block. I actually brought a sample along of pre-insulated block, okay? And we'll pass this around. We'll start with Bijan on the pre-insulated block here because this is going to be protected from the outside in. Why? The environment is what attacks a wall surface, whether it's stucco or poured in place concrete or it's block. That insert, that foam insert, is going to help to keep the temperatures more consistent. Now, what does that do for your client, Mike? What's the benefit of going with block? That means less loading of equipment. So they may not have to have such a sophisticated heating and air conditioning ventilation system, but they can have maybe a lesser, less expensive, but still high energy efficient type of a block building. And that's important too when looking at these aspects.
So this reduces the amount of grout, right?
Yes, it does reduce the amount of grout. It's still fully grouted, but only where there's space available to grout. And the other thing is condensation, okay? If we don't have good air barrier systems and we have weeps, okay? Last year, again, I was talking about waterproofing. If we don't have weeps at the bottom of our stucco, we're going to have problems and issues with mold and mildew and bacteria getting trapped. And then what's going to happen is we're going to see a paint or a coating that's going to start to discolor. And then it's going to start to get worse. It's going to start to peel and chip and crack. And then we're going to start to see the surface over time start to deteriorate. And we've seen applications, I have over the years, because I've been doing this for 30 years now, where we actually have structural problems. And that's really sad to see, structural problems. It's because we didn't understand the encompassing needs of a building. So pre-insulated block prevents that. There's no condensation issues with pre-insulated block. That's the real benefit there. Okay, any other questions
Can I
before we
ask a
move on?
question?
Yes, go ahead, please.
This insulation, percentage-wise, how much it affects of the insulation? Because in case we have a structural wall that requires to be fully reinforced by rebar and then fully filled up all the holes, I don't think we can use this in pre-insulation inside.
You can. You can, because you can use it. And I have some slides. So when we get to that slides, can we get back to your question? Because you'll see we do have applications where insulation is a help and an aid to the overall environment of the interior that's to be protected by HVAC. So that's a great question. We'll get to that a little bit later.
Ron makes great question.
Yes. Okay, now we're going to go into production, okay? This was a hand-cranked unit back in the early 1900s. I am told that, believe it or not, Sears, when they were known as Sears and Roebuck, sold these units. So what was the production of the Sears block? It was actually made by hand as far as the mixing of the water and the powder and the aggregates, okay? They mixed it for about 2 minutes. Then they put it into the hopper area and they turned the crank. It took about 12 seconds to produce 1 block. With today's present day automation, there are machines out there, and my company is among them, that can produce 3 block at a time in 6 seconds, 4 block at a time in 6 seconds, 6 block at a time in 6 seconds. So there's a rapid, progression with technical advancements, and this is just a wonderful thing to have because block can be put out now in sufficient quantities in a very short period of time. Okay, so then you say, well, Mike, how is cement block produced? Okay, well, it's a good question. Cement block is produced by first bringing in dry powder trucks of cement that pump in to these silos. Now, do we see the rust out here? Not very often. These are back east, maybe like in Ohio. But the thinking is they're pumped into these silos, okay, and then they start to be brought for the products with mixing of sands and aggregates up the conveyor belt and into a mixer. So they're all going to be mixed in a mixer. Now, the technological advancements are also better now because of the fact that everything's computerized, okay? So there's batching systems. I was in Oceanside. We have a plant that covers the San Diego area in Oceanside. 3 weeks ago, working a shift for a day with the people down there so I could get a better understanding as to how production works. So the mixer brings up the raw materials. A number 5 aggregate is one that I noticed on the outside coming in to these units, these mixers, and then they're brought into a hopper. What's in back of here is a hopper, and the hopper mixes color. There's a small little cylinder, smaller than this one, that has color that's added to it. The colors are dry pigments, okay? And then a minimal amount of water, okay? Not a lot of water. Why? Because it's called zero slump at that point. Because it doesn't slump. But I will say this, that when the block comes out in that last slide, out of the production line, it's like Jell-O. We could take our fingers in our hands and actually move it because it hasn't had time to cure. So these things do take time to cure. They don't come out automatically ready to go, for sure. Okay, here's the process, and what happens is the hopper then, which starts at the bottom, is taking the material to the top, and then it's dumping it in to this machine here for the production, okay? So it's being produced in that machine, and voila, here we go. We got 3 blocks over here. This is a 3-block machine, and it actually has excess aggregate and cement, and it's just something that there's a like little wet sponges or a line of a rod that basically knocks off anything that's excess that should not be part of the block itself on the top. And the guys down here, you may notice there's a wheelbarrow, so it basically catches the excess materials. Now, block manufacturers are big on reuse, okay? If you're talking about green, if any of you looked at my business card, ORCO won an award in 2014 for being the greenest company, period, in Orange County. So, talking about recycling and reusing our own products. If a block is not made properly, does it get tossed in the trash? No, it gets recycled. But recycling also involves aluminum and metals, glass. There's a lot of green materials other than just cement, sand, and aggregates that make it up. My manager said, Mike, you'd be surprised. I've seen things like Pepsi cans, pieces of Pepsi cans as part of block. And that is a natural thing. So these do happen. Now in the storage of them, they're stored briefly before they're sent into what they call steam baths. And the steam baths will take these units one by one, and they'll basically put them into what they call a kiln. A kiln is like a huge oven that forklifts will transport into a big kiln, where it's basically 16 hours in the kiln at a temperature between 110 and 150 degrees Fahrenheit. And then it's brought out and it's basically cooled. And then after it's cooled, it basically then will be sorted. But the key here for production is not only the quality and consistency of the mixing, it's going to be how it's also vibrated and how it's compacted, okay? So the key to get that 1900 PSI compressive strength or the 2000 PSI compressive strength that we have today is 2 things. It's vibration and compaction. Without vibration and compaction, you wouldn't get the proper compressive strength. It's the same for high strength. 3,750 compressive strength, you need that too. So all these things are very, very important that quality control is made properly. So as you can see, the forklifts is transporting them in and out, okay, and then there's an assembly line that has vibration and compaction until they basically get to the right side of the photo, and then by hand, they're inspected. Now, are there inspectors along the way? Yes, there are. I work with people, not only in Oceanside, but Riverside, where I was at earlier today, and Stanton, which is the corporate headquarters, and we have our plant in Stanton about a month ago, where they have tape rules. They have measuring tapes to make sure that an 8-inch block is 7 5/8. And you say, well, Mike, you're 3/8 short. Well, that's true, but we have to incorporate mortar as for the difference of the 3/8 to make it an 8-inch block. So it's 8 by, say, 8. So it's 8 wide by 8 high, and then maybe it's like 16 inches long, which is known as a standard block. And that's what these ones are. They're 8 by 8 by 16. Okay. Okay, now here, what's happening is this assembly is getting ready to break the block. Why are they getting ready to break the block? Because they're going to make it into a texture block that we know as split-faced block. So this is actually a splitter, is what it is. Okay? And basically, what we have is split-faced block for a lot of walls and buildings. that have what looks like peaks and valleys in them. They're not straight, they're not symmetrical, they're a little bit out in some areas and a little bit in. They're concave and convex technically, okay? That's a good way to put it probably. Now, the other thing I wanted to mention to you is that when we get, through the assembly line, sometimes, like I actually delivered these today to someone in West Hollywood. They wanted shop blast, okay? And why do they want shop blast? Because they want something more textured. They don't want it as open in the cinders, to see the cinders. These dark spots are the cinders, but they didn't want to see them as open. They wanted to see them more closed. So you have a little bit of cinder in view, and it's textured, okay? Now, you say, well, Mike, are all blocks like this? Do they all have scores like this? The answer is no. These blocks were specifically produced for windows and doors, because we need them to fit into windows and doors. The ones that aren't windows and doors, they're not going to have these typically, unless they're what they call vertical single score, which is what faces the public eye when we look at a vertical single score. We see that like in libraries, typically, other types of institutions. Then the truck is going to mount them and basically make sure that they're tied down properly before they ship them. And if you were wondering, how many blocks can go on a pallet? I'll tell you. If we go with the standard block, we mentioned 8-inch wide, 8-inch high, 16 inches long, we're going to get about 90 per pallet. So if we have a larger size, like say 12-inch, we're going to get less than that, okay? So just thought you might like to know how many blocks per pallet. Now here's split face block again, okay? We can see a little bit of unevenness, okay? But the split face block is one of 4 basic textures as far as finishes go. Earlier, I passed around starting with Mo, the precision block. This is a different color. That one's, I believe, a chocolate. Here we have a split face block. I'm going to give this one to Bijan. Here's your split face. That's white. I mentioned about shot blast. Here's the shot blast, okay? Shot blast has a texture to it. You can see some profile, okay? But then there's one last one. This one here is called burnish. It's very smooth. It's smooth like a baby's butt. Some people call it honed, okay? Some people call it glazed. This is a burnished block. And some people like the openness of the cinders. Some people don't. So Mo has a little bit of cinder visual. Bijan's passing on something that has a lot of cinder exposure. I have one last one that's not any different than the other ones we passed around because it is a burnished block, but it's actually has, instead of cinders, it has pumice. Pumice is white only, and it has a lighter weight on a block surface, but it can be produced in all the weights that are available. Here's an institution that many institutions like a smoother block. So this could be possibly a burnished application, okay? But some people want more than just burnished. They want something that looks really nice. Here we have a polished application, okay? And believe it or not, this does not have any sealers on it whatsoever, okay? This is made polished at the plant, okay? So it's a little bit unique because it looks like it has a seal. It's shiny. You see the gloss on it? Well, it's made that way, okay? So it can be done this way. It's amazing how things are made these days sometimes. And then there's exposure that they want a lot of texture in it, okay? These cinders are exposed, okay? They're textured. You rub your hand, it's like rubbing split face block. It's really textured, okay?
Do they still make the glazed block?
Yes.
that it looks like you have applied the ceramic, surface to it.
Yeah.
Glaze. I mean, Angela's Spot used to make it. I don't know whether they still make it or not.
It's not common,
It's not.
but it can still be made. Another one that is still around, but I think it's actually coming back, it's becoming more popular, is screen block. Screen block is becoming more popular. What is screen block, Mike? Instead of being a complete solid material, it has cuts in it, okay? There's a style called Cordova. There's another style called Tierra. There's another style called Mar-Jan. Mar being for March and Jan being for January. But it's called the opposite, not January or March. It's called Mar-Jan. What reason? I don't know, but it is. But there's different, some of them look like flowers, some of them look like stars, okay? Some of them look like lattice. You have lattice, but they're really nice and unique. And as you can see here, there's a lot of available shapes, okay? Sometimes, because you're working with corners, you're working with doors or windows, you cannot put a whole 8 by 8 by 16 block on the surface. So you get hacks, or you have them, if you have a lot of them, cut a special way, a certain special way, so that the block basically fits in to what is needed, and it looks like it all belongs and it all fits, because it does, and we can make those special block at the factory, okay? They can be produced. And the other thing is, these can be done for the last two slides, okay? These shapes can be done for polished, and they can be done for textured, like we saw in the last two slides. Integral water repellent. Remember I mentioned earlier about 1601 Lincoln Boulevard, that block building over there for the new transit center, okay? They've chosen a dark color. They've chosen black, okay? You mentioned Angeles earlier, ORCO. We have at ORCO at least 4 black colors, and a 5th one is made sometimes too. But an integral water repellent sometimes comes in handy, not so much for the lighter colors, but they come in handy for the darker colors. Why? Because the darker colors have a tendency to effloresce. They have a lot more moisture that shows on the surface, and then when it dries out, it chalks, it effloresces. So for the darker colors, and this is what the transit center wants because they're going with black, they want an integral water repellent. But I'll also say, not only do we want to do the block, we also want to do the mortar for it, okay? So the mortar also needs to be with an integral water repellent. So what does that do? Does it waterproof, Mike? The answer is no, it does not waterproof. Is there an increased cost? Yes, there's an increased cost. But it's something that it gives your client a better peace of mind because they don't see that unsightliness of efflorescence, okay? And when there's test run, okay, there's no water repellent. How long does it take? 1 minute, 5 millimeters of water, completely absorbed. But with the water repellent, after 15 minutes, nothing has been absorbed. So what do we want to do technically? We want to create a hydrophobic condition, okay? That's key for using a water repellent. Okay, now we're going to go to the next section, which is the overview of Astm C90. And in Astm C90, you can see 8 different bullet points here, which are minimum requirements for load-bearing CMU. Now, there's something on the left which we have not seen before. It's called a tech note, NCMA tech note. There's a whole big binder available, or of course online. What is NCMA, Mike? It's the National Concrete Masonry Association, okay? It's another governing body, okay? It's people who provide us guidelines for practices, okay? This is NCMA, what Bijan has 7, which is a fire rating, okay? There's fire rating information. It's very important for buildings that need to have a 1 hour, 2, 3, 4 hour fire rating. This is what helps us here. But they're all part of the criteria. So, Mike, what has changed over the years? Well, back in 2000, the standards were developed for what's called Type 1 moisture controlled and Type 2 non-moisture controlled units of the CMUs. Units designations were removed from there. The standards of Astm C90, they were removed at that time. However, we still see some specifications out there that have not been changed or altered. Is there anything wrong by having Type 1, let's say? It cannot, but it also can. It all depends upon the moisture considerations that need to be made for a block wall or a block building, okay? But in 2013, fire resistance came into play, web thickness. What's web thickness, Mike? Okay, again, 5 months ago, I didn't know what webs were. When we have open or closed webs at the end of the block, these are open-ended, okay? We could also have closed-end block, okay? Closed-end block has what's called 3 webs. Open-end, in this particular case, has 2 webs. When we mentioned about pre-insulated block earlier, the technology has advanced that we only need 1 web because both ends are open-ended. Now, what does that do, Mike? That prevents, to a large scale, what's called thermal bridging. Why do we want to avoid thermal bridging? Because thermal bridging is where we have areas of a room for HVAC that are not as consistent in their heat or their cold of the rest of the room. So by having less webs, we have a more controlled temperature in the rooms. So where the technology was once 3, then it went down to 2, and now there's 1. But does everybody have 1? No. Most producers of block around the United States and in Southern California have 2 webs, but we have 1. Okay? More consistent temperature.
Is that only if it is left exposed inside and outside, or it doesn't matter whether it's covered with, if you do a fair out, on the interior side of the concrete block,
right,
inside the room, you do a fair out and
yes,
then drywall. But does that affect, what you just said about the thermal?
The furring will only help because some people will use furring strips that are wood, other people will use furring strips. The furrings come in because of the availability of raw materials. In most of the country, they deal with normal weight. We go to San Diego, we're going to see more normal weight, okay? In Los Angeles, Orange County, the Inland Empire, we see more medium weight because it encompasses the features and the benefits of both lightweight and normal weight, and it's priced in between the 2. Anyone have an answer for me? You get bonus points tonight if you answer it correctly. Can anyone tell me between lightweight, medium weight, and normal weight, what's the most expensive? Any idea?
The medium weight, isn't it?
I wish you were right. You're close though. You're right next to it. Lightweight actually costs the most because it's the hardest to obtain. And in Northern California is where the quarry is. So the producer in Northern California has better access than we do. We don't try to go to Northern California to do projects. We only try to do projects here in the LA and Orange County and Inland Empire and San Diego. So we know where it's best. The least expensive is actually normal weight, but it has the highest density. So you say, well, Mike, what's the advantage of lightweight? The advantage of lightweight is for fire reasons. What's the advantage of normal weight? It's for sound, okay? So sound is enhanced. And again, the medium weight encompasses both. So what's the least expensive when you look at the end of the day? It is normal weight, but medium weight is pretty close price-wise. Okay, so with that in mind, there's another mention here of 2 other ASTMs. The C331 on the bottom, that's lightweight. The rest of the aggregate products for medium weight and for normal weight are going to fall under Astm C93 as far as what the aggregate itself must conform to.
Is there any imports CMU in USA?
It would put us out of business. Everything's local to a region. I won't say local to Southern California because it's not. When somebody needs lightweight and we're going to make it here in Southern California, if the job's in Southern California, we have to go to Northern California for
I
getting
mean,
it.
importing from overseas, is there any? No.
Good question, Mo.
No Chinese.
No Chinese. Hey, that's one thing, no Chinese. Okay, there's a game here. Very good. Okay, so here we have CMU properties affected by density. We look at fire resistance. The best suggestion is lightweight. Sound control, normal weight. Water penetration and absorption. We're looking for something more dense here, so we want normal weight for that. Energy efficiency, normal. Structural design influences, the medium weight. Aesthetic considerations, any of the three, take your choice. And productivity, lightweight. We'll see a slide shortly as to why lightweight is the most productive. As far as fire resistance, we mentioned earlier, Bijan had a great question when it came to fire resistance. He just didn't know it. But he asked about fully grouted block. You know, is it an advantage to have fully grouted block? Well, for fire resistance it is, because with any of the three weights that we mentioned, lightweight, medium weight, normal weight, you can get, with a fully grouted block, a 4-hour fire rating. You can't get any better than that, okay? Sound transmission class, okay? For the sound transmission class, we have here 8-inch, okay, which is a normal weight, and 10-inch, which we don't use unless it's a real extreme applications, and sometimes we go with 12-inch block. Lightweight CMU has a lower sound transmission class than normal weight does, okay? So lightweight would be good for fire, but it's not as good for sound transmission. There you need a normal weight block. So you call out and you specify for a normal weight block. In that case, you get better sound absorption. Now, if a normal 8x8x16 block is not sufficient for sound transmission, there is another product that we can produce that has inserts, kind of like the pre-insulated block, but it's not insulated with the polystyrene foam. There are inserts that are added to a specially made block that give a higher STC, sound transmission class, that's needed. However, the California Building Code and Chapter 24 do come into this. So the good news is block producers like the company I represent do have the necessary compliance to codes. We mentioned earlier about water penetration and absorption, and as far as water penetration and absorption, the normal weight does work better for the applications when those are of importance. And as you can see, a lot of these still have the tech notes that we passed around earlier. The tech notes are important. For energy efficiency, okay, we mentioned earlier that medium weight has its advantages. Lightweight units have a higher R value. The inverse or the converse way to say it is lightweight units have less thermal mass and heat capacity. We're going to go into that.
Can we add waterproof additives into the concrete block to make it waterproof?
That's
Have
something.
they done that at all?
Not the technology hasn't gotten there. I don't think the technology is going to get there. And Bijan, you present a great question. The reason why that concrete block is not waterproof is because it needs to breathe. And that's why only water repellents can be effective. Because what would happen is, let's say we had a rainstorm. I think we were expecting showers of rain today, as a matter of fact, okay? If we have an untreated area side by side with a treated area, the untreated area and then the third one. We have a third one which is waterproof, let's say, okay? The first one, the water's going to saturate, okay? The second one, which is the water repellent area, the water's going to be, and then cascade down. It's going to fall down the wall. The third one, the water can't get in, but like concrete, if we have a slab of concrete or a wall of concrete, it's got to breathe. You shut off you create a vapor barrier, we have structural problems. And it's true for block also. So it's not a good case to have waterproof problems. In fact, I'll give you an example. Next week I'm going downtown to see the architect who's working on the soccer stadium. And for the soccer stadium, they asked to have a water repellent product, an anti-graffiti product as a second choice, and then the third one having a higher solids, but a solvent-based product that complies to South Coast Air Quality Management District, which means it has to be 100 grams per liter. All three of them are going to be applied on a side-by-side basis, a third and a third and a third. Okay, what happens with all of them is they will darken the surface, but the problem we fear with the solvent-based product that's higher solids is the water may be repelled, but it actually has a sheen on the surface. And with the sheen on the surface, that means that there may be something deleterious that could develop into cracking, peeling, and chipping. Even though it goes on darker and you really can't see any sheen level and gloss on the surface, over time it will actually invert itself and come back out in the form of cracking, peeling, and chipping of the sealer. So it gets unsightly. That's the last thing we want for a high-profile project like the soccer stadium over there where the sports arena used to be. Okay, so now we're going to go to color. As far as color goes, all the conditions of normal weight, medium weight, and lightweight, okay, you can be using the same pigments, but they will look different in the block. So what I'm saying is the appearance will be different. So that's why we believe in getting samples to you. When you need samples of block, please contact me and we'll produce samples for you to give you, because all three will look and appear different with the same colors. This is very similar to our plan. Yes, sir, I'm sorry, go ahead.
You're talking about lightweight aggregate. What is heavyweight aggregate? What is the difference between these aggregates?
Well, the aggregates are going to be larger size, but there's also going to be sand. So the sand and the water and the cement are going to kind of be like the glue, but the heavier weight materials are because the aggregate is larger size. So that's why we mentioned earlier about normal weight. Normal weight block is the heaviest block that's available. There's no heavy block. It's normal weight. And that's why the density is higher, 135 pounds per cubic foot or higher. So it is the heaviest weight that's available to normal because the aggregate is larger. It's larger aggregate. Yes, sir.
And the same question, when you're talking about the percentage of the mixture, for example, 10% of the red aggregate,
Yes.
we are talking about 10% of the weight, not the volume.
Right.
So it really doesn't matter if the aggregate is larger size or a smaller size, because it doesn't matter if it's a big one piece, one chunk, or little pieces, right?
Right. Right.
So it shouldn't have any effect on the total weight of the block. That's my observation.
Well, something has to give it more densifying to be more dense, and that's why there's different sizes of aggregate. We don't always use the same size aggregate. I mentioned number 5 earlier, but I've also seen, depending upon what plant that I'm in, like a number 8, which is a smaller size. So yes, you're right. There's different densities of block. Good question. Did I answer your question, sir?
Yeah, that's good.
Did I answer your question, sir?
Yes.
Thank you. For these here, there's aggregate trucks, there's sand trucks that bring it in and they drop down into a holding chamber area before that they're used and brought by conveyor up that conveyor line to where the mixer is at the top of the line. So all these are used on a daily basis. Now, the one that's up here, this one here is a sand binder for medium weight. Okay, down here it's a white for medium weight, and then there's a darker one. Okay, so it all depends on what we need to do, and then follow up with quality control assurance to make sure to get the color produced that you have for the sample in your hand. We mentioned about lightweight earlier. One other advantage for lightweight is it's easier on the mason to make the system work, to do the wall assembly. So there's less fatigue. In fact, this is a picture of the insulated block. Okay, there's a double open end, like here, but there's actually only one web. I don't have the pre-insulated block with me tonight. Sorry, that's why I got two webs in this. But this is at the Otay Mesa Detention Center. This was a job that was done about 4 years ago now, and it was the first using a single web system. So it not only was for security reasons why they use this block, but it was also to have a more controlled environment there at the detention center. This is in San Diego, and I actually saw it back in December when I first started with the company. The local rep down there did the specification with a local architect for this detention center. And there's been others that have popped up since, one of them in San Diego, and there's another one coming up in Monterey. Okay, I mentioned earlier that normal weight has its advantages, lightweight has its advantages. We could add a third column here and put medium weight. The nice thing about medium weight is it will show X's in each of these categories. So here in Southern California, producers like Angelus, someone mentioned Angelus earlier, and ORCO subscribe to medium weight when it's applicable to use medium weight.
So if we have a project and depending on the type of the use and also the effect that we wanted in our building,
Sure.
we can call you and ask you for you to give us some advice on what type of a concrete block we should specify, right?
There we go. That's the way to do it. Yes, sir. Thank you. That's a great question, and happy to do that. Again, we're going to be going into thermal mass shortly. That's part of it, and we'll be getting your insulation a little bit later. But I just wanted to point this out that medium weight does really good. Now, for testing, this is evaluating compressive strengths. What do we do here? There's two test methods. The normal method that we see most of the time is called unit strength method for compressive strength testing. However, if we had an institution, a school, a hospital, talked about a detention center a few moments ago, most likely the municipality will tell us if they want a unit strength test or if they want a prism test. So the more demanding the application, a commercial type application or institutional application, the prism test will be done. We're going to go into the actual testing itself so you can see how it happens. This is the unit strength test. Okay, it's always going to be done by a third-party testing lab. Okay, and here we see different higher arrow points. So that means that the compressive strength is actually being tested as high as it can go. We want to see what the failure rate is going to be. So when we hear a bang at this lab, that's where the unit, the CMU, has failed. And that's where the number comes out, such as 2,000, 2,100. For our medium weight, our average is about 3,000 compressive strength. So we're well above the ASTM number on that, but that's where it fails. When I worked for Hilti, I had a structural engineer and a civil engineer to work with. When we cranked an anchor, we wanted to see what the failure of that anchor in the concrete was going to be. And that's what gave us the tensile strength, okay? And then the shear value. Where did it shear, okay? They were all failures. That's where the number is actually recorded, is the failure. Now, the prism test, okay, can produce more accurate results. It's something where it's generally performed when high-strength structures are required. Institutions, bless you, Sam. Hospitals, schools, okay? Higher demand needs. That's where the prism test is done. And it's independent also. Now, here's where thermal mass comes in. This is a real important point in tonight's presentation. We can look at heat capacity. The heat capacity assesses thermal mass. What kind of capacity for an area like this room do we have to work with, okay? The definition of thermal mass is the amount of absorption, okay, and how it penetrates into a protected area, okay? So you say, well, Mike, then what is thermal mass, okay? That's where the absorption and the storage of these amounts are. So, we look at common materials. We look at wood, we look at tile, concrete, brick, and lastly, concrete block, CMU. Wood has a low thermal mass. The rest of them are high. So what does that mean, Mike? That's what the R values and the U factors come in. So although it says it depends upon not only climate, and it's applicable to cooler climate, colder climates, it's applicable anywhere in the United States as far as being able to understand the need for thermal mass. Thermal mass is good, okay? It is. Now, we have here different block applications as far as the density of the blocks. Flip to the area that I need to go to. Okay, the more the dense the block, the greater the heat capacity of different wall assemblies. On the first chart here, it's hard to read. These are all U factors with lightweight, medium weight, and normal weight block. Okay, so we're going here to cured, partly grouted, and then full cell grouting. Okay, so it encompasses all of them. But the best thermal mass is where you have a fully grouted wall assembly. Okay, that's the best. Down here, these aren't applicable to us in Southern California because they have no grout. Here's your insulation, sir. Sorry it took you so long to get there, okay? Thermal performance is based on R or U factors and thermal mass, as we spoke just a moment ago. Exterior insulation, interior wall is usually finished with wallboard, okay? So we have a perimeter of block, insulation, and more block, okay? And the concrete masonry backup is continuous, okay? And in some cases, veneers is going to be used, okay? Exterior stucco or insulation systems and synthetic stucco, they have different requirements than we do because they have a synthetic finish, the stucco. Thermal mass is inside the insulation there, ideal for colder climates. The masonry is in contact with indoor and air conditioning. Now, I mentioned earlier about thermal bridging, okay? This is where less webs is better. So if we have 2 webs on a block rather than 3, that's an enhancement. If we have 1 web because we're going with pre-insulated block, that's the optimum, okay? But we don't always need optimum. It costs more for optimum, okay? But the good news is you know now that if it's needed, a producer like us has it.
Now, is the 1 web more expensive than the 2?
Yes, it's about 30% more expensive in material, but the nice thing about it is it's produced at the factory, okay? So that means the mason doesn't have to do anything except that photo that we saw with the Otay Mesa detention center, excuse me, the Las Colinas is where it is, because there is another one in Otay Mesa too, in San Diego. But there they had a double open end, and there wasn't 3 webs, there was only 1 web. So that means less problem issues, potentially I say, with thermal bridging, because the entire area is better covered. We don't have spaces that could be susceptible in a protected area where there's block by having more than one.
mortar. I mean, we use more mortar also.
We
to
do.
fill the-
Right.
Because it's a one-way.
Right, we do. The good news is we have polystyrene to help us there too. So yes, your point's correct, but we also have enhancement. And I don't know if you noticed it, gang, but this is not completely symmetrical, okay? Because one overlaps another, okay? It overlaps here, it overlaps here. So there's no gaps. I mentioned condensation earlier. No issues with condensation. We're good. Another question I wanted to ask of you. Does anybody know what creates mold and mildew? One of my stops was with Frazee Paints many years ago. And when I was with Frazee Paints, I belonged to the PDCA, Painting Decorative Contractors Association. We need to have, to prevent mold and mildew, light, not darkness, ventilation, not stagnation, an organic food source should not be present. Drywall is an organic food source, okay, so that feeds, okay? So sun, light, and presence. The last one, the fourth one after organic is moisture. If we can shut off one of those environmental elements, we don't have a problem with mold and mildew. But if all four of them are present, look out, okay? Just thought I'd let you know of what I learned over the years. But mold and mildew is an important problem with condensation, you know, and it's something that we don't always think about. But the good news is, if we go pre-insulated block,
But stucco doesn't have organic, right?
Right.
Compared to drywall.
correct. Stucco, you don't have that problem. So for a frame building, you're in good shape there. We don't have issues. But sometimes, if it's not, if the building is not properly insulated, that's where the conditions change, and we have potential for issue. We're just about done, gang. Okay, back to thermal performance based upon the R factor, R value or U factor. This is where I mentioned earlier about a molded polystyrene insert, like we've shown in the sample. Foam in place or loose fill insulation. Last year, I represented a manufacturer who had foam, okay? It's a good product, but we don't have any solids issues. This is 100% solids. Foam in place is about 90% solids. So Mike, what does that mean? It means that there's potential for shrinkage, deformation over time, and that's where condensation comes back into play. Okay, so we're really better off by having, and I mentioned, Dijon, 30%, okay, it takes a little bit longer to install, because you got to make sure that the foam is mounted correctly before, well, of course the rebar is there too, but before you grout it, you got to make sure everything's right. So it takes a little bit longer to install a typical block. Does it have to have a mortar on it? Yes, because again, if it's 8 by 8 by 16, it's 7 5/8 by 7 5/8 by 3 5/8. So you do need to fill the voids with mortar also, but it's about 40% more to have a pre-insulated block than it does not to have it. So I'd share that with you. Now, there's 3 compliance methods as far as for single wife masonry units. The prescriptive one, the performance trade-off, and the whole building analysis. We're briefly going to touch on this. The prescriptive is what is dictated. Municipality basically will tell us, or if it's a state project, state of California, Sacramento is going to let us know. Performance and trade-off, there's variable conditions, and then there's a whole building analysis, which is something more recent over the years that has come into play. So for the prescriptive, there are a couple of different tables that are based upon section of the IECC, 502 and C402. For R values, there's also U factors, 502.12 and 402.12. So a little bit different, but the years are consistent with each other. So for single white walls with R values, the table cannot be used because of continuous insulation requirement. Okay, so unfortunately, the R value is not something that is applicable. The U tables can be used to comply with the code because ASHRAE recognizes that. And because ASHRAE recognizes it, then the codes here in California do allow the U factors. So we need to look more at U factors rather than R factors. And why? Because sometimes when we are looking and evaluating, we need to keep in mind of different types of materials, wood, metal, besides block, concrete, okay? So by looking at the different building materials and looking at R factors, maybe there's a call out for a metal building for R19. For block, it's 2, if it was applicable for an R factor. For U factors, they're kind of inverse, which means that they're going to be lower. It's actually 1.45 for U factor. Of that 2R, it's 1.45. So they are inverse of each other. And again, U is the way to go. Now, for effective R values, it's the same thing. Because they don't comply to code here in California, we can't use them. The Department of Energy also does not accept them. As it says, ASHRAE does not recognize them either. So it does not meet code. And when we can, we want to have a professional do some calculations known as a com check calculation. A mechanical engineer needs to do this, okay? So this is an important procedure to do when we're looking at different types of insulation and an analysis for the whole building. This is the section in the code that refers to the total building performance, as far as HVAC and power, lighting, the loads. This is probably the most accepted as time goes along, is the whole building envelope process analysis. Now this is the last thing. 3 levels of compliance as it has to do with air barriers. Individual building material, the assembly of materials, and the whole building envelope, okay? The individual building material is intended to serve as an air barrier. It must have an air permeance. So this is where there's permeation, okay? We want air to get through a surface from one side to another. We don't want it to be cut off, okay? The air permeance should be less than, for the individual building material, 0.004 of a cubic foot per square foot, okay? As far as the differential, and this is in accordance with ASTM.
This is before assembly of the wall, right?
Yes.
This is just for the one block. The
Correct.
testing on one block, not on the whole,
Not on the whole thing. That's correct. Good point. We mentioned about 15 different, at the bottom here, 15 different building materials in the 2012 IECC code, okay? Look what's in there. This is one of the 4, but it's actually 15. Fully grouted CMU, okay? Compliance, right there, bang. Okay, now we'll look at the second one. The assembly of materials intended to serve as an air barrier must have a permeance of less than 0.04 of a cubic foot per square foot at a pressure differential. And there's 3 different ASTM listings that it complies to, okay? Now, the assemblies deemed to comply, CMU walls with either 1 application of block filler and 2 applications of paint sealer or sealer coating. So when people say, hey Mike, I'm going to have a perimeter wall hypothetically, I don't care what it is, I want the least expensive, I'm value engineering this wall, what do I use? And specify, what do I call out? I would call out the one we showed first, the gray one. We had 2 of these, and these are precision. This is the least expensive to make, but it's the most widely used. especially if you're going to have either of these happen to it. You're going to have a parch coat, stucco over it. A lot of people end up with that stucco look, but what holds up the wall? CMU block, believe it or not, with some rebar. It's a good thing to do. Yes, you're doubling the efforts, but if your client wants something to look nicer than block, go ahead and do what you need to do with one of these two finishes, please. I'm not going to be offended, I promise. These 5 assemblies, again, all come back to what's acceptable as far as the codes. And again, we're looking at the tech note for section C, section 6, the control of air leakage in concrete masonry walls. Do we have that with grout, fully grouted? Yes. Block walls, paints and coatings? Yes. The nice thing is about paints and coatings that are breathable, we talked about breathable, is that there's paints and coatings that you can put on block that keep them breathable, okay? So yes, you can do that. Gypsum board, exterior wall insulation, all these comply with the 2012 IDCC for air barrier compliance. And I promise this is the last slide. Air leakage rate of building envelope shall not exceed 0.4 of a cubic foot per square foot at a pressure differential of 0.3 water gauge in accordance with the ASTM E779.
Now that pressure difference, I mean, is that the normal condition that we have here in Southern California? Or is that, can we say that we have, that condition here normally?
Yeah, because it's something that with permeance,
That pressure difference?
that pressure difference is a compliance to not only ICC, but the codes will look to IDCC to make sure it is. So it's a normal CFM rating, 0.4 in this case, where air leakage is important for the building envelope without exceeding. And that's it. I've taken up a lot of your time this evening. You've given me an hour, and I've taken up all of it. May I ask for questions or comments? I'd be happy to talk with you about products over the tables. As Bijan was so nice to mention earlier, not only does ORCO manufacture block and mortar products, they also manufacture pavers. Now for projects where you say, Mike, I don't need block, I have stone, I have brick. The mortar, which is a joint grout, can be used for stone, brick, any kind of masonry type materials. But if we have a value engineer need, and we know that brick may not go through with the people that are the structural engineering people and building, we actually have block that looks like brick. And yesterday I delivered what's called spec brick. If anyone's interested in spec brick, I'd be happy to email you. For whatever reason, I brought the insulation flyers, which are 4 pages, double size, there's only 2, not much to take home with you. But I also have information on spec brick. And yesterday I delivered the Delaware blend of spec brick, which had what we call a Baltic or an Otay brown. And I don't have an Otay brown in the box, but it's darker than chocolate brown. And it also has a darker color, a light black that's associated with it. But in driving through Delaware, New Jersey, and Pennsylvania, and Maryland last week, I saw my share of what I think I perceive as a Delaware color. As far as the pavers back there, some people want bevel pavers because they look really nice, and you're going to basically fill the seams with sand, okay? Most people put pavers over compressed dirt that has rock and aggregate on it to basically make it stable, so we don't have to worry, hopefully, about sinkholes. But the real advantage of pavers, in my mind, for both pedestrian pavers and vehicle area pavers is the fact that they are permeable. So where we may have problems with flooding on concrete, or if it's a clay surface of dirt, okay, we may not have as much infiltration because it's going to stay and lay on the surface with heavier rains or prolonged periods of time. The good news is we have permeance with pavers. We talked about permeance earlier, so I hope that helps. Yes, sir.
Let's say that we have a wall that we have a requirement for the R value of the wall. Let's say, just hypothetically, 19.
Okay,
And we're using one of your blocks that is only 2
right,
R value.
right,
Now, if we come up with a design, an assembly
yes,
that increases, that R value, we're getting closer to what we need.
right.
Would your engineering, ORCO, your company, would they help us, to go through the engineering and see what this R value, so we can prove it, to the building department, that this R value now is, let's say, 15, 16, or 19? Or we have to do it on our own, just use yours and then add whatever we want to it?
The mechanical engineer would be the best
Would be-
person to help us. I would solicit to a mechanical engineer. Now, don't get me wrong, Bijan, we do have engineers on staff, but they're not for calculating or helping us to increase our value. What they're there for is to make sure that structurally perimeter wall systems are specified properly as far as what goes into them. Our group charges nothing for this. It's going to save about $1,500 from a civil or a structural engineer to do as far as what they would charge. We charge $0 because you're specifying, you're calling out for our block, and the mason's going to bid it and install it appropriately. So when we're looking at perimeter walls, retaining walls, segmental retaining walls, and systems like that are not part of buildings, that's where our engineers, we have 2 staff engineers in Riverside, but that's all that they do all day. They actually call themselves overhead. They're people like you and me, but Mike, I'm overhead. I'm here to help the architect and even the structural engineer at times. And we stamp our plans. These guys are certified by the state. They have to go to school on a regular basis. One of them was at school about a month ago. The other one went to school about 2 years ago, but he's getting ready to retire pretty soon. So, not real soon, but one of these days. But those guys are for segmental and retaining walls, segmental retaining walls and perimeter walls with help of engineering, and not for, unfortunately, what Bijan's question was based upon. Mechanical engineers are the best.
Thank you very much. Thank you.
Thank you. My pleasure. Did everybody sign in on the sheets that you need to sign in? You have your AIA numbers for those of you who need to put AIA numbers. If you want a certificate, we will get you a certificate, whether you're an AIA member or not.